Hello, in this lecture we will find the radius of the small circle. In the drawing we have two circles. The circles have internal length at this point. Let's call this point N. Point N is the point of contact of the two circles with each other, and also the small circle have three tangents. This line segment is tangent to the small circle at this point. Let's call this point S. Point S is the point of contact between the small circle and its tangent. We also have a second tangent to the small circle at this point. Let's call this point Z. Again, point Z is the point of contact between the circle and its tangent. And we also have line segment CD that is tangent to the small circle at this point. Let's call this point M. Point M is the point of contact between line segment CD and the circle. Actually, CD is tangent to the circle at point M. Okay. In the next step, we will define the radius of the small circle as R, or small r. Small r is the radius of the small circle. Okay, small r is the radius of the small circle, and let's define capital R is the radius of the big circle. Okay, capital R is the radius of the big circle. Okay, capital R is the radius of the big circle. We also know that AB is the diameter of the big circle. Okay, AB is the diameter of the big circle. Or chord AB is the diameter of the big circle. That is to say, AB equals to 2 times the radius of the big circle, or AB equals 2 times capital R. Okay, and we also know that AC equals to 9 units and dB equals to 4 units, and we also know that this angle is a right angle, and we also know that this angle also equals to 90 degrees. Let's define the center of the small circle as point Q. Point Q is the center of the small circle, and let's define the center of the big circle as point P. Again, point P is the center of the big circle. Okay, that also means that PB equals to capital R, that is the radius of the big circle, and also AP also equals to capital R, the radius of the big circle. Okay, PB equals to the radius of the big circle, it equals to capital R, and AP also equals to the radius of the big circle, it equals to capital R. Okay, and in the next step we will draw three radiuses of the small circle. The three radiuses will exit from the center of the small circle to the points of contact between the circle and its tangents. Okay, so the first radius of the small circle will be this radius, and we have a rule that states that the radius is perpendicular to its tangent. That is to say, R is perpendicular to its tangent. So this angle is 90 degrees, and we will draw the second radius of the small circle to the point of contact between the circle and its tangent, to point Z. So again, the radius is perpendicular to its tangent. So we have here the radius and the tangent to the circle. So the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees. Okay? We also know that this angle is 90 degrees. So we actually have here we will draw the second radius to the point of contact between the circle to line segment CD. That is to say, we will draw the radius from the center of the circle to point M. So actually QM is the radius of the small circle, and again the radius is perpendicular to its tangent. CD is tangent to the circle and to the radius. For that reason, the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees, and this angle is also 90 degrees. Okay, so actually we have square QZMD. Okay, we have square QZMD. Square QZMD has 3 right angles. So actually 3 times 90 degrees is 270 degrees. Okay, so the sum of the 3 angles in square QZMD is 270 degrees. And we have a rule that the sum of the angles in a square equals to 360 degrees. The sum of the angles in a square equals to 360 degrees. Again, we have a rule that states that the sum of the angles in any square equals to 360 degrees. And we know that 3 angles of square QZMD equals to 270 degrees. So the fourth angle must be equal to 360 degrees minus 270 degrees in order to complete the sum of the angles in this square to 360 degrees. The fourth angle must be equal to 360 degrees minus the sum of the 3 angles minus 260 degrees. So 360 degrees minus 270 degrees equals to 90 degrees. So actually this angle is also 90 degrees. For that reason, if you have a square that has 4 right angles, then this square must be a rectangle. So shape of square QZMD is a rectangle. Okay, square QZMD is a rectangle. Okay. Okay, again, square QZMD is a rectangle because it has 4 angles that are right angles. For that reason, this square is a rectangle. And therefore, we know that in any rectangle, the opposite sides are equal to each other. And we know that QZ equals to R, so MD must also be equal to R. Okay? So MD equals to R, and we repeat on the same process on square SQCM. Okay, in square SQCM, square SQCM has 3 right angles. 1, 2, 3. Okay, square QZMD as 3 right angles. And we know that the sum of the angles in a square is 360 degrees. So for that reason, the value of the fourth angle, the value of this angle must be equal to 360 degrees minus the sum of the other three angles, minus 3 times 90 degrees. That is to say, the value of this angle is actually 360 degrees minus 270 degrees. That is equal to 90 degrees. Okay, so the fourth angle, this angle is also a right angle. Okay, so for that reason we have shape SQCM that has 4 right angles. Therefore, shape SQCM is a triangle, or square SQCM is a triangle, and we know that the opposite sides of any triangle are equal to each other. So if SQ, we know that SQ equals to R, so CM must be also equal to R. Okay, so CM equals to R. Okay, CM equals to R, and if we define PM as X, if PM equals to X, okay, PM equals to X, then CP will be equal to R minus X. Okay, so CP equals to the radius of the circle minus X. Okay, CP equals to R minus X. Okay, so we will create the first equation for the radius of the big circle. We know that the radius of the big circle equals to AP. AP equals to R. AP is the radius of the big circle, so AP equals to capital R. Okay, this is our first equation. But what is the value of AP? The value of AP is actually AC plus CP. Okay, AP equals to AC plus CP. Okay, AP, that is the radius of the big circle, equals to AC plus CP. So AP, that is the radius of the big circle, that is to say, that equals to capital R. It equals to AC, that is 9 units plus CP. We've already found out that the value of CP is R minus X. CP equals to R minus X. So AC plus CP is 9 plus R minus X. Okay, so from one side, the radius of the big circle equals to capital R, that equals to AP. Because of the fact that P is the center of the big circle, the radius of the big circle equals to AP. And what is the value of AP? AP equals to AC plus CP. And AC equals to 9 units, and CP equals to R minus X. So in total, AP, that is the radius of the circle, equals to 9 units plus R minus X, that is CP. Okay, so we calculated the radius of the circle from the right side. Now we will calculate the radius of the big circle from the left side. Actually, the radius of the big circle, capital R, equals to PB. Okay, PB is the radius of the big circle, and but what is the value of PB? PB equals to DB plus MD plus PM. Okay, PB equals to BD plus MD plus MP. Okay, again, PB, that is the radius of the big circle, equals to BD plus DM plus MP. Again, PB, that is the radius of the big circle, equals to BD plus MD plus MP. Okay, so we can write down that the radius of the big circle equals, the second equation is that the radius of the big circle, that is to say capital R, equals to BD, that is 4 units, plus MD, that is the radius of the small circle, or MD equals to small r, plus MP. MP equals to X. Okay, so we calculated the radius of the big circle from the other side, and we got that the radius of the big circle equals to 4 plus R plus X. And according to equation number 1, the radius of the big circle equals to 9 plus R minus X. Okay, so equation number 1 and equation number 2 are both the expressions of the radius of the big circle. So we can write down equation number 3 that states that R equals to R. Equation number 3 states that R equals to R, and in the next step we will substitute R, this R, by equation number 1, and we will substitute the other R by equation number 2, and we will get that 9 plus R minus X equals to the value of R from the second equation equals to 4 plus r plus x. Okay, so equation number 3 states that r equals to r. So r of the first equation r equals to the r of the second equation. That is equation number 3. Here in equation number 3 we have here it is actually r plus small r. Okay, in equation number 3 we have r of equation number 1 is 9 plus small r minus x. It equals to the r of equation number 2, that is 4 plus r plus x. So actually in equation number 3 we have small r in this side of the equation and we have small r on the other side of the equation, so r is cancelled, and what is left after r is cancelled is 9 minus x equals to 4 plus x. Okay, we got that 9 minus x equals to 4 plus x. We will subtract 5 from equation number 3 and we will subtract 4 from equation number 3 and we will get that 5 minus x equals to x. We subtracted 4 from equation number 3 and we got that 5 minus x equals to x. Here we will add x to equation number 3 and we will get that 5 minus x plus x is 5. Equals to x plus x is 2x. Okay, we got that 5 equals to 2x. Here we will divide equation number 3 by 2 and we will get the value of x. Okay, so 5 over 2 is 2.5. So we got the value of x. X equals to 2.5 units. Okay, we found out the value of x. X, that is actually PM, equals to 2.5 units. So we have equation number 1 that states that the value of the radius of the big circle is actually equals to capital R equals to 9 plus R minus X the radius of the big circle equals to 9 plus r minus x, but we have already found out that x equals to 2.5 units, so we can add x in the third equation by 2.5. units, and we will get that capital R, the radius of the big circle, equals to 9 plus small r minus 2.5. 9 minus 2.5 is 6.5, so we got that the radius of the big circle equals to 6.5 plus small r. Okay, we found out that the radius of the big circle equals to 6.5 plus small r. Okay, capital R equals to 6.5 plus small r. Okay, in the next step we will present a rule number 1, and we will implement rule number 1 in our drawing. Rule number 1 states that if two circles have an internal lunge between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. So I will read rule number 1 again. Rule number 1 states that if two circles have an internal lunge between them, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, that is rule number 1, and we can implement rule number 1 in our circles. Actually, in our two circles there is an internal lunge between those two circles. and the interval length between those two circles is at point N. That the two circles are touching each other at point N. So they have an interval length between them. For that reason, we can use rule number 1 that states that if two circles have interval length between them, then the distance between their centers are equal to the difference between the lengths of their radiuses. So here actually the center of the small circle is at point Q, and the center of the big circle is at point P. So the distance between the centers of the two circles is PQ. The distance between the centers of the two circles is PQ, and according to rule number 1, that distance PQ equals to the difference between the length of the radiuses of those circles. That is to say, PQ equals to capital R minus small r. Again, we implemented rule number 1 in our circles. That means that the distance between the centers of the two circles in the drawing, that is QP or PQ, equals to the difference between the length of the radiuses of the two circles. That is to say, PQ equals to capital R minus small r. Okay? So here we will add r small r to equation number 4, and we will get that capital R equals to PQ plus small r. So according to equation number 4, capital R equals to PQ plus R. But we have already found out and from equation number 1 that we have already know that capital R equals to 6.5 plus small r. Okay, we have already found out that capital R equals to 6.5 plus small r. Okay, and again we will create equation number 5 that states that R equals to R. Okay, according to equation number 5, R equals to R, and then we'll substitute this R by equation number 4, and we'll substitute the other R by equation number 1, and we'll get that PQ plus small r equals to 6.5 plus small r. Okay, we substituted this capital R by equation number 4 and this R by equation number 1. We got that PQ plus small r equals to 6.5 plus small r. Here we have small r in this side of the equation and we have small r in the other side of the equation. So r is cancelled and we found out that PQ equals to 6.5 units. We found out the value of PQ. PQ equals to 6.5 units. And we also found out that X equals to 2.5 units. So here we will connect together points P and Q by a straight line. And we know that this is angle QMP is a right angle, it equals to 90 degrees. Therefore, triangle QMP is a right triangle. Okay, triangle QMP is a right triangle. Triangle QMP is a right triangle. Therefore, we can use the Pythagorean theorem in order to find out the value of MQ, that is the radius of the small circle. We know that PQ equals to 6.5 units. We know that PM, that is X, equals to 2.5 units. And the only missing variable is MQ, that is the radius of the small circle. And we will use the Pythagorean theorem in order to find out the radius of the small circle. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, PQ square equals to PM square plus QM square. Okay, the square of the hypotenuse, that is PQ square, equals to PM square plus QM square. We know that PQ, okay, according to the Pythagorean theorem, PQ square equals to PM square plus OM square. We know that PQ equals to 6.5 units, so PQ square is 6.5 square equals to PM square. PM square is X square because PM equals to X, so PM square is X square plus QM equals to small r. QM is the radius of the small circle. Okay, we got that 6.5 square equals to X square plus r square, but we have already found out that the value of X is 2.5 units. X equals to 2.5 units. Okay, so we got here that 6.5 squared equals to 2.5 squared plus r squared. Okay, we substituted x by 2.5 because x equals 2.5 units, and we got that 6.5 square equals to 2.5 square plus r square plus small r square. 6.5 squared is 42.25 and 2.5 square is 6.25, so we write it down. Okay, we got that 42.25 plus 6.25, 22.25 equals to 6.25 plus small r square. Here we will subtract 6.25 from this equality, and we will get that r square equals to 36. Okay, we subtracted 6.25 from this equality, and we got that r square equals to 36. Here we will take a root out of this equality, and we will get that r equals to the root of 36. The root of 36 is 6, so we found out that the radius of the small circle equals to 6 units. Okay, the radius of the small circle equals to 6 units. Again, the radius of this small circle equals to 6 units. Okay, so now I will summarize the lecture. We wanted to find out the radius of the small circle. The small circle is inside a bigger circle, and actually those two circles have internal launch between them at point N. Again, those two circles have internal launch between them at point N. And we also know that AB is the diameter of the big circle. And we know that AC equals to 9 units and BD equals to 4 units. And this angle is a right angle, and this angle also equals to 90 degrees. Okay, and we want to find out the radius of the small circle. Okay, first of all, we defined small r as the radius of the small circle, and we defined big R as the radius of the big circle. Okay, big R is the radius of the big circle, and small r is the radius of the small circle. Again, AB is the diameter of the big circle. So AB equals to 2 times the radius of the big circle, 2 times capital R. Then we defined point Q as the center of the small circle, and we defined point P as the center of the big circle. So actually AP is the radius of the big circle, and also PB is also the radius of the big circle. So PB equals to R, and AB PB equals to R, and AP also equals to R. Again, AP equals to R and PB equals to R. Okay, AP equals to capital R and PB also equals to capital R, that is the radius of the big circle. Okay, we know that in the drawing we have actually 3 tangents to the small circle. This is the first tangent to the small circle. This line segment is tangent to the circle at point S. This line segment is tangent to the circle at point Z, and this line segment CD, is tangent to the small circle at point M. Okay, in the next step we draw 3 radiuses of the small circle to the points of contact, between the circle and the tangents to the circle. Okay, so QS is the radius of the small circle, and actually the angle between the radius of the circle and its tangent is 90 degrees, because we have a rule that the radius is perpendicular to its tangent. For that reason, this angle is a right angle, it equals to 90 degrees. And we have QM, that is the radius of the small circle, and M is the point of contact between the tangent of the circle and the circle itself. For line segment CD is tangent to the circle at point M. Therefore, this angle is 90 degrees because the radius is perpendicular to its tangent. The radius R is perpendicular to its tangent CD. For that reason, this angle is 90 degrees and this angle is also 90 degrees. Then we drew the third radius, and the third radius starts from point Q and ends at point Z. Point Z is the point that this line segment is tangent to the circle. This line segment is tangent to the circle at point Z. Therefore, the radius is perpendicular to its tangent. Therefore, this angle is right angle. It equals to 90 degrees. Okay, so actually we have square QZMD is a square, and the 3 angles of the square QZMB are equal to 90 degrees. So the sum of those 3 angles is 3 times 90 degrees equals to 270 degrees. And we have a rule that states that the sum of the angles in any square equals to 360 degrees. Therefore, the fourth angle must be equal to 360 degrees minus the sum of the 3 angles, that is 270 degrees. 360 degrees minus 270 degrees equals to 90 degrees. Therefore, this angle is a right angle. So actually, we have a square with 4 right angles. Square QZMD has 4 right angles. Therefore, this square is a rectangle. QZMD is a rectangle. Okay? Any square that has 3 right angles is a rectangle. Therefore, square QZMD is a rectangle, and we know that the opposite sides in any rectangle are equal to each other. So actually QZ is equals to MD. QZ equals to MD, but QZ is the radius of the small circle. QZ equals to R. So QZ equals to MD. That means that MD also equals to R. Okay, we proved that MD equals to small r, and we repeated on the same process on square SQCM. On square SQCM we have three right angles. This is a right angle, this is a right angle, and this is a right angle. So in square SQCM we have three right angles. Okay, and we have the rule that states that the sum of the squares, the sum of the angles in any square is equal to 360 degrees. So especially in square SQCM, the sum of the angles is equal to 360 degrees. So we know that the sum of the three right angles is equals to 90 degrees times 3 is 270 degrees. So the fourth angle must be equal to 360 degrees minus 270 degrees. That is to say, the fourth angle is also a right angle. It equals to 90 degrees. So in this way we actually proved that square SQCM is a rectangle because it has three angles that are right angles. For that reason, square SQCM is a rectangle. That is to say, its opposite sides are equal to each other. That is to say, SQ equals to CM. And we know that SQ is the radius of the small circle. It equals to small r. SQ equals to CM. That means that CM also equals to small r. So we proved that CM actually is the radius of the small circle. Okay? In the next step, we defined PM as x. PM equals to x. And we actually calculated the radius of the big circle in two different ways. We know that AB is the diameter of this big circle. That means that it equals to 2 times the radius of the big circle. So the radius of the big circle equals to AP, because P is the center of the big circle. So the radius of the big circle equals to AP. Okay? But what is the value of AP? AP equals to AC plus CP. Again, AP equals to AC plus CP. Okay? AP, that is the radius of the big circle, equals to AC plus CP. And we know that AC equals to 9 units. And we know that CP equals to R minus X. CP equals to CM minus PM. Again, CP equals to CM minus PM. That is to say, CP equals to R minus X. Because CM is R and PM is X. So CP equals to R minus X. So in total, AP equals to AC plus CP, that is R minus X, or AP equals to AC plus CP. That means that AP equals to 9 plus R minus X, because CP equals to R minus X. And AP is the radius of the circle. So we got that the radius from one side, the radius of the big circle equals to 9 plus r, small r minus x. And we also calculated the radius of the big circle from the other side. The radius of the big circle equals to PB, because P is the center. So the center of the big circle. So PB is the radius of the big circle. Okay, PB equals to capital R. But what is the value of PB? PB actually equals to BD plus MD plus MP. Again, PB, that is the radius of the big circle, equals to BD plus MD plus MP. PB equals to BD plus MD plus P plus MP. Okay, that is the value of PB, and we know that BD equals to 4 units. MD is the radius of the small circle, that is to say it equals to small r, and we defined PM as x. So PB, that is the radius of the big circle, equals to 4 plus r plus x. That is our second equation. The second equation is the calculation of the radius of the big circle from the other side. And we already found out that the radius of the big circle equals to 9 plus r minus x when we calculated it from the other side. From this side, we got that the radius of the big circle equals to 9 plus r minus x, and when we calculated the radius of the big circle from this side, we found out that the radius equals to 4 plus r plus x. So then we created equation number 3 that states that r equals to r. Okay, r equals to r. So r, as we calculated it from the one side of the equation, equals to the same r as we calculated it on the other side of the circle. Okay, this r equals to this r. Okay, so we substituted r, this r, by the first equation, and we substituted the other r by the second equation, and we got this equality, and we found out that x equals to 2.5 units. And if x equals to 2.5 units, we know for equation number 1 that the radius of the big circle equals to 9 plus r minus x, and we already found out that x equals to 2.5, so we can substitute x by 2.5, and we got that the radius of the big circle equals to 6.5 plus small r, according to equation number 1. Then we presented rule number 1, and we implemented rule number 1 in our two circles. According to rule number 1, if two circles have an internal lunge between them, that is to say, if they touch each other from inside, then the distance between their centers is equal to the difference between the lengths of their radiuses. Okay, the distance between the centers of the two circles is equal to the difference between their radiuses. That is to say that if the radius of the first circle is r1 and the radius of the second circle is r2, then the distance d between the two circles will be equal to r1 minus r2. Okay, so we actually implemented rule number 1 in our circle, because here we have two circles that have internal length between them at point N. They touch each other from inside at point N. Therefore, we can implement rule number 1 in our two circles. According to rule number 1, the distance between the centers of the two circles, and the distance the center of the small circle is at point Q, and the center of the big circle is at point P, and the distance between those two centers is PQ. PQ is the distance between the centers of the two circles. That PQ, according to rule number 1, is equal to the difference between their radiuses. That means that PQ, that is the distance between the centers of the circles, is equal to capital R minus small r. Okay? So we have equation number 4 that states that capital R equals to PQ plus small r from one side, but from the other side, we know for equation number 1 that capital R equals to 6.5 plus small r. So we can compare equation number 1 to equation number 4 that states that capital R equals to capital R. Then we substituted capital R, this R, by equation number 4, and we substituted the other R by equation number 1, and we got this equality, and we found out that PQ equals to 6.5 units, and we have already found out that X equals to 2.5 units. Then actually connected together by a straight line points P and Q, and we know that this angle is a right angle, so therefore triangle PMQ is a right triangle, so we can implement the Pythagorean theorem in the right triangle PMQ. The Pythagorean theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, PQ square equals to PM square plus QM square. According to Pythagorean theorem, PQ square equals to PM square plus QM square, but we know that PQ equals to 6.5 and PM equals to X. And the only missing variable is R, because we know that X equals to 2.5 units, to 2.5, and PQ equals to 6.5 units. And the only missing variable is the radius of the small circle. So we solved this simple equality, and we found out that the radius of the small circle equals to 6 units. Okay? The radius of this small circle equals to 6 units. Okay, thank you very much.